I don't know about Brendan, but I know Daylan's out this morning, so it could be just the two of us, three of us.
My Wi-Fi is going in and out. I had trouble staying on in bio, so if you ask me a question I don't answer it away, that's why.
Okay. Not a big deal. We'll work with it. I was thinking I will go through that chapter 7 assignment right now. All right. I've got to mark them, so I'm going to mark them after we're done on here this morning. And I'll get back to you. And then we will go through wherever we left off last week, which was 8.3, wasn't it?
Yeah, it was 8.3 when we left off.
Okay. There only are the 3 sections.
Skip class on Friday.
Yeah. Okay. Yeah, we had an hour and a half long staff meeting, so it didn't work very well. Okay, why don't we, I'll go through. Mary, do you have your assignment with you right now? Yeah? No?
Sorry, Mr. Dude, I had trouble getting my stuff working here. What assignment?
The chapter 7 assignment. I'm going to go through it with you right now.
Okay, I'll get it.
Yep.
Are we the only ones here? Historian time?
Yep.
Yeah. I think, well, Daylin texted me that she's away, and I don't know where Brendan is.
I'll text Brendan right now.
Yeah, sure. Sounds good. Okay, so it says sketch an exponential function with all the given conditions. So the domain is x is the number of all reals. The range is y is less than 0. A y-intercept at -4. No x-intercept, and the function is always, we should have had decreasing. I remember switching that, so I have to remember to do that. There's Brendan. Okay, Brendan, we're going through the, we are going through the chapter 7 assignment right now.
Okay.
Okay. I'm just pulling up the assignment on my computer. I needed, oh yeah, I did switch it already. Okay. All right. So just an example then of an exponential function then. Should have that drawn in. All right. And then any shape where it approaches that line and then turns away from it is fine. So that means there's no x-intercept, which we should have gathered that from y is less than 0 anyways, and then it had to be decreasing. So that's all there was to that question. So it's a fairly straightforward 4 marks for it. I didn't ask you for any equations. It just asked you to sketch it.
I have a question.
Go ahead.
Didn't we talk about this, like we asked you, like there was something wrong with the question?
Yeah. The last line of the question says the function is always increasing, and we switched it to decreasing.
Yeah, so if you did that, like the question is different, the answer is different, because you did it as an increasing on board.
Yeah, you know what? I agree with you, Mary. I don't think it was necessary for us to change that. And a function can increase and hit a certain point, but it continues to increase as it gets closer to zero. So the way it's worded is actually correct, because you always start from left to right in terms of your increasing and decreasing function. And if it's down here, like you're basically doing it because as x gets larger, what is happening to y? Well, y is also getting larger. It's just by an infinite or a very, very small amount, right? So that question was actually worded correctly. So if you did decreasing, it would have to be this.
Yeah.
Okay, so I'm not sure. I just didn't read that question proper when you asked it, but the question was worded correctly. It is an increasing function. I'm just going to switch it back now that I fixed it once.
I didn't really find much of a problem with that. Like I think I did it the same as increasing, and it made sense.
Yeah. Okay. All right, let's look at the second question now. For the function y equals 1/2 3x to the minus 2. It says describe the transformations of the function as compared to y equals 3 to the x. All right, so basically, there's my a, b, c, and d values. So my a, what's happening is I am stretching the y's. By a factor of 1/2. So I'm multiplying all my y values by 1/2. Okay? And then I'm moving the whole thing right too. Okay? So that's pretty straightforward. Again, the best way to do these that we've been doing all along is do the A, B, C, and D and then work it through that way. All right? Okay, so now it says draw it. Okay, so I've got y equals 3 to the x. All right, so what I want to do then is find some key points. So key point number 1 is 0 and 1. So I could use 0 and 1, 1 and 3, and 2 and 9. And all I'm doing is putting x values in for x and then write them out. All right, so because of a, I have to multiply the y values by 1/2. Okay, and then I got to move them all to the right. So that becomes 2 and 1/2, 3 and 1/2, 3 and 3/2, and 4 and 9/2. So basically what I'm doing is just moving this all to the right. And because it's this equation here, if I put 0 in here, That makes that -2. So 3 to the -2 is 1/9. So this would be like 1, this would be 0 and 1/18, actually, is what that becomes. And which would be down here. And that's what my graph would look like. So I would have 2 and 1/2 and 3 and 3/2 and 4 and 9/2. So that would be the way to do it. Now, what's imperative or what's important for this is this guy right here. We need that. We probably should have that. You'd always want your intercepts in there for it. And then the other two are just to help guide you, but not necessary. So the domain for this, the domain is x is an element of all reals. The range for this is y is greater than 0. Y is an element of all reals. And the equation of the asymptote is y equals 0.
Mr. Newton, do you mind shifting the camera down just a tad? I don't want to see that.
That better?
And to the right a bit. Then down a little bit more. Yeah, that's perfect.
You're good? You see it all now? Okay. All right, I'll leave that up there for a second. Any questions about that? No? Go to the next one. We're okay? Wants you to solve for x. Okay, so the first thing we do is we check to see if we can get the same base. If that's possible, then that's what we do. I can change this to 3 squared, x subtract 1, and I can change this to 3 to the -1, x subtract 1. All right, oh, this should be 4x subtract 1 here. Okay, so now I've got 2 times x minus 1 equals -1 times 4x minus 1. Get rid of my brackets. Add 4x. Add 2. I believe the answer is 1 in this case.
I got something different.
I do too.
Yeah, I got 1/2.
What did I do wrong here? Oh, this should be a 1, not a 4.
Oh shit, I can't see your screen. I'm just gonna like X out and then.
Okay, I won't go any further. You're good. So I ended up with 6x equals 3. X is equal to 1/2. That's what I get for that. I don't know if it's an N or an X. Okay, so I ended up with x equaling 1/2 for that. Let's give Mary a second to come back on. You guys are okay with that one?
Did you figure it out, Mr. New?
Yeah, it's a half.
Okay, nice.
I had messed this up here. I had a 4 instead of a 1 there.
Okay.
Okay? All right, so the next one is rewrite that in the correct form. So one of the things that we learned throughout the process of graphing square roots and graphing polynomials is that you do not want to have that negative directly in front of the x. The same thing occurs here. So if I'm to rewrite this, it's y equals 2, negative 2, x plus 2, add 6, like that. Okay, so therefore, A is 1, B is negative 2, C is negative 2, and D is 6. Describe the transformations that must be applied to the graph y equals 2 to the x. So I'm going to divide all my x values by negative 2. So a horizontal stretch of a half, negative half reflected over the y-axis. Good?
Mr. New,
Yeah.
the question is y equals 2 to the negative 2x plus 4 originally. So you have minus 4, which should be. So that when you factor it out, it should be minus 2.
Yeah, so your C value should be a positive 2, not a negative.
Yeah. What? Yeah.
Oh, and the original. Sorry. So up here. Okay. Yeah, I see what you're saying. Plus 4, negative there, and then that would make this still a negative 2, but this becomes a plus, right?
Yeah.
Does that look right now? Okay, so I have a horizontal stretch by a factor of negative 1/2, or a reflection moves right 2 and up 6. Okay, that makes perfectly good sense to me. So we got to move that. So our 0 and 1, or sorry, yeah, 0 and 1 stays 0 and 1 because of B. Here, I'll just write it out right here so we understand. Stays 0 and 1, moves 2 to the right, so that's 2 and 1, and then up 6, so 2 and 7. So this guy right here goes over here, 1, 2, 2, 3, 4, 5, 6, 7. So it'd be somewhere up here, right? And then the y-intercept for this one, put a 0 in there. That's looks like 22. I put a 0 in here, that makes that 4. 2 to the 4th is 16. 16 and 6 make 22. So it would be, oh yeah, I have a stretch. So, sorry, this is going to be an ugly graph. Let me do it on here so I can show you the proper way to do it. So that's what that graph would look like. So it's going to go through 2 and 7, like I said, which is right here. Whoops. So that's 2 and 7. And then it's going to go through the y-intercept up here, which is 0 and 22. So those would be basically the two key points that you would need on this graph. Obviously, I drew the graph poorly, sketched it, so maybe I better change that graph, make an adjustment to it. Okay. Well, that was it for questions. Okay, so I'll get those marked and back to you today. All right, so I need to change that last graph out on that question. Okay, all right, any questions about that assignment? We okay? All right, questions today from 8.12 or 3. Anything from 8.12 or 3?
Just give me a second. I'm looking.
Yeah, no worries. I'm not going anywhere.
I have trouble finding one. Sorry, 8.1 question.
What page?
264.
Okay. And which one was it on 264?
Just that question 3.
All of 3?
Yeah, I just don't.
Okay. Yeah, that's easy enough. Okay. So if you have something in logarithmic form and they ask you to change it to exponential form, this guy right here is your base. Even in logarithm, we call it our base. What we do is we say the log of y to the base b. Okay, so whatever this is the base. Well, what you learned in grade 10 with exponents is you have a base and you have a power. Okay, so the base value is that the large number, and then the power is the exponent, right? Well, I make this go up to this side, and I get y is equal to b to the power of x. This becomes my power or my exponent. This remains as my base in exponential form, and then y is equal to that. So when I look at number 3 then, I have the log of 32 to the base 2 is equal to 5. All right? So this stays as my base, but I put it to the other side and I change it from a logarithm to an exponential. So I go 32 equals 2 to the power of 5. And that should be the same on both sides. 2 to the power of 5 is 32. So if I look at b, so I leave 512 on the left side, and I raise it, 8 to the power of 3. So my base value in my logarithm and my base value in my exponent, they don't change. They stay the same. All right?
I can do the rest.
Okay? Perfect.
Mr. Newton, when there isn't any log value, it's always 10, right?
That's, yeah, if there's no base value.
There's no base value. Yeah.
Yes,
It's always 10.
that's correct. And what you learned in applied was this too. We haven't seen this yet in this part of the course, but if you had this, the natural log of x, that was the same as base e. Okay, and remember e was like similar to pi in that it was an irrational number that goes on forever. Okay? All right. Other questions from that whole section? Like we haven't...
On 278.
Absolutely. Question 3?
Question B, so 2B.
2B? Sure.
Yeah.
And we are changing, are we expanding it? Is that what we're doing? Okay.
Yeah.
Okay. So you have a choice right now. The first step is very key because you have a choice of 2 things. The first thing would be to move the 3 in front of the log, but I wouldn't do that personally. And the second choice is the choice that I would use, and that would be to distribute the 3 first. Okay, so I would change this into so I would have transferred that 3 through the brackets and made it this. And then now I would go 3 log x to the base 12 plus 6 log y to the base 12 plus 15 log z to the base 12. And that would be my final answer. Okay, Mary, are you all right?
Yeah.
So this one is set up so that you take the exponent and you move it to the front. That's the basic logarithms that we're utilizing in this one. Okay. All right, let's keep going. Anybody else? Mary, any others?
Can we try the one after, just how you do with the square root?
Sure. Okay, so I'm going to change that guy to an exponent right away. So I take the square root and I turn it into an exponent of a half. Okay, and then I would do the same thing I did in the last question. I would multiply that by the exponents inside the bracket. So I go log x cubed over y to the 1/2 z to the 5/2 base 8. Okay, and because they're both on the bottom, I would subtract the 2 of them. So I'm going to use 3 log x base 8 minus 1/2 log y base 8 minus 5/2 log z base 8. Okay, so I move the 3 in front, make it log x base 8. I move the 1/2 in front, make it 1/2 log y base 8. I move the 5/2 in front, make it 5/2 log z base 8. And in each case, I subtract those values.
What about 3A?
3A? Okay. So we got to write this, then evaluate and simplify where possible. Okay. So we want to expand each expression. Okay. So the first one I'm going to do is I'm going to write it as log 49 base 7 add the log of x to the 5 over 3 to the base 7. Okay, so that step there, I changed the cube root to a third and I multiply it by that 5. So that's how I get the 5/3. Okay. Now what I'm going to do is I'm going to move that to the front. And this guy is going to become log 7 squared to the base 7. So plus 5 over 3 log x base 7. I move that 2 to the front. What's the log of 7 to the base 7? 1. So I got 2 plus 5 over 3 log x base 7. There's my final solution for that question. Okay. This section becomes pretty important. We need to be able to convert from expanded to singular and singular to expand form. All right, anything else from 8.1 to 8.3? Nope. Okay, how about 8.4? Did we start it?
Yeah.
Brandon, Rory, did you start 8.4?
I did like the first part of the first question, and then repeated that.
Okay.
Okay.
All right. Okay. Let's, I didn't go through examples on this yet, so I only went through the one example on page 282. So let's go through that this morning. Okay. All right. So I'm going to go through 1C, page 282. So on your, if you were to write a provincial exam, one of the very first 4 or 5 questions on the exam comes from this section. And it either involves changing to a single logarithm and then changing it to an exponential function, or taking an exponential function and changing it into a single logarithm. So this guy, when I have logs like this, I change it into a single logarithm and then I convert it to exponential. So the first thing I do is I combine into a single one. So this is x minus 3, x plus 6. I make sure they're both bracketed. 6 equals 2. Okay? So now that I have a single logarithm, I can now convert that into an exponential function. So I go x minus 3, You know what? I'm going to skip a step here, okay? I'm going to FOIL that. That gives me x squared minus 3x minus 18 equals. So I'm changing that. I'm taking this base and moving it to the other side, so I get 6 squared on this side. So I move this up to the other side and change it to exponential. I get x squared plus 3x minus 54 equals 0. 36, I subtract it to this side, and then it's a case of factoring. And in this section, you're going to find lots of times the values are going to give you extraneous roots. And one way we tell is this cannot ever equal a negative number. So obviously in the first one here, the negative 9 doesn't work. 6 works, but the negative 9 doesn't work for that. So like I said, this is one question you can guarantee you would see on a provincial exam. And then the second question from inside in this is on page 285. This is another one that is in the first 4 questions on the provincial exam because you need to use your calculator for it. So this would be another thing that you would need to be able to do. So let's look at page 285. Let's look at 2C. This would be as hard as it gets. So I have 3 to the 2x equals 7 to the x plus 1. Now these questions are a lot of work. So I'm going to go through it and I'm going to show you how to do all the work for this question. So the first thing, going in front of the camera, the first thing you could actually do a little less work by graphing it. That is one way to do it, but in which you would graph and find out where they intersect. That's a possibility if you wanted to do that. Algebraically, there's quite a bit of work here to do. So the first thing I do is I take the log of both sides. So this becomes log 3 to the 2x, which equals log 7 to the x plus 1. Now that I have the log on both sides, I can now convert using my logarithmic rules, and I can take the exponents and put them in front. So this is going to give me 2x log 3 is equal to x plus 1 times the log of 7. Multiplied through the brackets. Okay, so this is where it gets to be fairly new to you what you would do at this point. Okay, and we did this in the applied course, so there is still that. So I'm going to get the logs with the x's on the same side, and anyone that doesn't have an x goes on the other side. So I'm going to subtract this to this side. So I get 2x log 3 minus x log 7 equals log 7. So I have the x's on the same side now. That is the only reason I do that is so I can factor the x out. So I factor this x out right here. That's going to leave me with 2 log 3 minus log 7 equals log 7. And to get my final answer, I take the log of 7 and I divide it by I divide it by 2 log 3 minus log 7, and I use my calculator at that point. So I punch that into my calculator. Again, I've changed it all to base 10, which is what my calculator works in. I need to use brackets on the bottom. And that's what I end up with. You recall seeing this in applied?
Bits and pieces of it.
Yeah, it's going to take a bit of work. Remember, these were long questions. So basically what I'd like to see you do is get to the end of question 4 today on 8.4. Oops. I'd like to see you get to the end of question 4 on 8.4 today. That would be a good start. All right, questions? All right, so if you can finish 1 to 4 today, that would be ideal. And we will work through 5 to whatever it is, 10 tomorrow on it. Okay. Any other questions about this course today? No? Okay. I'm gonna